Okay, so in this first review worksheet, we're going to look at function features, things you got to know about looking at dissecting the graph of a function, for instance. And we're also going to plug into it algebraically. So this function, I have the algebraic form of the function, this guy. There's the algebra. And as far as I know, I kind of did this one in my head, but the graph of that looks like this. We can check it in our calculator, right? You guys could even do that, no problem. Let's just skip it this time. And so we're going to do a variety of things with it. We're going to plug some numbers into it, and we're going to answer some questions about it. So first, if I plug h of 6 in, you can use the algebra or the graph. Which one do you think is going to come out as the exact answer? If I use the algebra and I put 6 in, or if I use the graph and put 6 in? You can do it either way.
Algebra.
The algebra is going to come out exactly, though, yeah. I mean, like, I drew this by sketching it from my knowledge of rational functions. I might have been wrong even, and I definitely could have like not scaled it right, you know what I mean? But looking at my graph, if you put 6 in, here's 5, so 6 looks like it's supposed to be what? 0, so let's see if that is correct. Okay, let's put 6 in the algebra and see if it comes out as 0. Alright, so if I put 6 in, then I'm going to take 6 and drop it in all the x slots, right? So I use that notation. So I'm going to put that in, and we'll get what? 6 times 6 minus 36. We're going to put 6 squared minus 2 times 6 minus 10. So this also gives you some nice practice on order of operations. You got an order of operations going forward. You can't have stumbling blocks on that. So order of operations says parentheses, exponents, multiply, add, right?
And also division, add, and
Yeah.
subtract.
Yeah, right. So I think of multiply and divide as the same thing. I think of add and subtract as the same thing. You're right though, Katie. Very nice. So there's really parentheses here. Where are the hidden parentheses? You guys who have computers open need to close them. This is not amateur hour, Cody. Oh, computer closed. Richard, do too. Okay, so where are the imaginary parentheses? I heard it. There's like one here for the top, and there's one here for the bottom. It doesn't matter which way you go first. You don't even have to write those down. I mean, that's how you should be thinking, though. So on top, I could go 36 as 6 times 6 minus 36. I'm going to get what? 0. Okay. So then on the bottom, we got 36. We're doing the exponent. Then we're going to do the multiply. And then on another step, we can put all that stuff together with subtraction or whatever. Does that make sense? Okay, so now we've got negative 22 and 36. It's 36 minus 22, 14. And 0 over anything solid like 14. If you have nothing, you cut it into 14 pieces and you give it to your friends. How much are you giving your friends?
Nothing.
You're giving your friends nothing. It matches the graph. Nice. Okay.
0 at all. You don't even have to find the other parentheses.
Right. On some of these problems, you might end up with not 0 on the top, but 0 on the bottom. Let's see if that happens. So we're going to keep plugging other things in. So when we plug 2 in, what's going to happen? So if we plug 2 in, we're going to get 6 times 2 minus 36. 2 squared minus 2 times 2. It's going to be 12 minus 36. 4 minus 4 minus 10. It's going to be negative 24. 4 minus 4 is nothing. Negative over negative is positive. I think that's going to come out as 2.4. So let's see if that matches my graph, kind of. If you put 2 in, do you get 2.4 out? 2 in, could that y value be 2.4?
Yep.
Yeah, I think so. 1, 2, 3, 4. So that looks good enough. Okay? All right. Why don't you guys try plugging in 0 and negative 3? Go ahead and try those for a second. If you're watching the video, you want to try plugging in these last 3 and see what you get. So if you haven't paused it and worked through these, you definitely want to do that now. So if we plug in 0, I think we should come out with this. We have 6, drop 0 in, drop 0 in here, drop 0 in here. Right? 6 times 0 is 0, minus 36. Okay, I did the top, inside. I go on the bottom, 0 squared, still 0. That's still 0. minus 10. So I get negative 36 over negative 10. Negative over negative again is positive, so that's going to be 3.6. Or you could put it in your calculator. If you put something like that in your calculator, fine. So let's see, did that make sense? At 0, do we get 3.6? My graph's a little bit off, so it should have been a little higher. Okay? Let's see, negative 3, if we plug that one in. This is a really important one, too. Some of you are messing this up, and I will definitely have things that will catch you on the final if you still can't do this. So negative 3, dropped in. Okay, so I want you guys to look at how I wrote that down and tell me what is extremely dangerous about the way I wrote that down. Like if you used your calculator and simplified this, it's going to tell you the wrong answer right now. I saw Richard and Mary. I don't know who's first.
I'm not about that, but with the graph thing, how is it 3.6? Because whenever you plug in like an equals like 2 or something, it goes from like 2 something. Or like something.
Yeah, my graph's a little off. Like this should be higher. Yeah?
How does it get to 2.4 if it's higher?
Yeah, the shape doesn't make sense, does it? Let's plot those 2 points. So we had a point at what? 2 and 2.4 was it?
Yeah, 2.4.
So that'd be like right here. And then we had a point at 0 and 3.6. This is 2. So that'd be something like right here. So I know from logic, from algebra 2 or whatever, that this is never going to come down here and cross and have this kind of shape because there's only one x-intercept on this function. If you look at this algebraically and you factor the top, you guys can think about this right now. You factor the top, they share 6, right? You pull 6 out, you're going to get 6x minus 6, aren't you? That tells you, the top tells you about all the x-intercepts you're going to have. What's the only x-intercept we're going to have? If we plug in 6 here, we'll get 0, which is the one that I tested a second ago. That's this guy. Are there any more places that you could make the top 0? There are not. So that means there is no other place this crosses. So if it doesn't do that, I think that by symmetry, like my parabola E shape, it's not a parabola, but my parabola E shape in the middle should have been more like this way, over that way, something like that. Nice catch, you guys. Okay. So back to the negative 3 thing, we're just plugging it in, because that's some advanced math right there, I guess. A little bit more advanced. What is extremely dangerous there? What is going to cause the calculator to mess you up or whatever? The negative 3 squared. What should I do with it, Cole? I should. If you don't put this in your calculator as parentheses, it's going to tell you negative 3 squared is equal to what? What's it going to say? It's going to say negative 9. But we all, of course, know if you square a negative number,
It becomes positive.
it becomes positive. This is supposed to become positive 9, so you got to be real careful about that. Because now order of operations says go inside first and then square it. So that's a little thing you got to be careful about. So let's see, 6 times negative 3 is negative 18. Minus 36. It's going to be positive 9, not negative 9. And the minus times minus is plus. Simplify, this is all negative, right? So you might need your calculator. What is 18 and 36? I might need my calculator.
It's negative.
54? Thanks. And then we've got 9 and 6 is 15, minus 10 is 5. I don't know what that is. Can you guys tell me what that is? A decimal. So we want to think about it on a graph, right?
Negative 10.
So I think my graph is messed up again. We're supposed to have a y value of negative 10.8 on my graph. So I did something wrong. I was doing stuff wrong in my head. Let's see. Does this guy factor in the bottom?
Yeah.
Good to review factoring too, anyway. I tried to make it factor. Does it? 5 and... I was going for 5 and 3, that's where I messed up. I always do that with 5 and 3 and 5 and 2. Does it factor right now? The only choices are 10 and 1 or 5 and 2. Do 5 and 2 give you 2? It gives you 3. So let's fix this a little bit.
You're changing it to fit
I know. So if we make that 3, then it'll factor as
5 and 6.
5 and 2. Sweet. So that would change this a little bit, right? It would change this to minus 3. So it's going to be plus 9. 9 plus 9 is 18 minus 5 is 18 minus 5 is 18. Oh, 18 minus
10 is 8.
and so you're right. Man, crazy. All right, what's this one? We're gonna fix my graph up here.
75.
Okay, so at negative 3, it's supposed to be down here at negative 6.75. So something like this. Yeah?
Yeah.
So this line I had is actually supposed to be negative 2. So this would go like this. And then we've got a piece down here, which means this piece would look like this. Okay? So negative 8, if you guys got negative 8, why don't I give you another second? Try negative 8 if you haven't already. So negative 8, I'm thinking if my graph is correct that it should be like negative 1, negative 2, something over here, okay? So we've got, that's 3, 4, 5, 6, 7, 8. Okay, so when you do negative 8, I think you should get negative 1.07 about, which I think matches what we were thinking about for the graph. If you go negative 8, could that be like negative 1? Yeah, totally. So now it's looking good. I think we fixed it up. So let's look at some of these other questions here. So it says when y is 4, what is x? Where on the graph is y 4? Here it's negative 4, negative 3, negative 2. It's up here, right? Like there's negative 4. So you want to think about this and where the actual graph is that. I think here or here. So there's two values that would work. Let's just estimate them. So from the graph, what do you think this one is, x-wise? Negative 1, something like negative 1. So we'll say about negative 1 and 3, 3.5, something like that. Okay? There's how you do that. Where is h increasing? Where is this graph going up? Is it going up? You read all this stuff left to right. Is it going up here? No, it's going down. Is it going up here? No, it's going down until about that spot. And then it's going up. So from here to 5. So you use interval notation to say that. You want to go from about 2, not negative 2, from about 2 right there anyway, to 5 it's going up. Is it going up anywhere else?
No.
From here it's going up, up on my graph until about there. That's about 6. This is about 7. So I think from 5 to 7 it's also going up. We'll put parentheses on both because we're not exactly sure. And what symbol do I put in the middle here if I want to count this one or this one? Because there's nothing in common between these. It's the U, meaning union, one or the other. That's the or symbol, okay? So where is it decreasing? Where is it going down? Well, everywhere else, right? Like it's going down from negative infinity all the way until, where's this one? Negative 2. And then it kind of jumps over. It keeps going down though until 2. And then it starts going down again at 7. So I'm going to put another or and go from 7 all the way out to infinity. It's going down, 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 down. So that's increasing and decreasing. Domain and range is even more important. When you have a graph, it shouldn't be a struggle to decide where it's increasing, where it's decreasing. Graphing it's the tricky part, right? That's the part I was taking a lot of time with. I had to fix my mistake and everything on that. But looking at the picture and deciding this stuff shouldn't be a big deal. When you look at the domain, domain is all the x values on the graph or all the y values? Can you guys remind me? Yeah, domain is all the x values, all the x parts that exist. So x values, what do we have that exists? Well, it exists all the way until here. It doesn't exist right here. At -2, it doesn't exist. We got to skip that. So we're going to say negative infinity. We don't want to count -2, open circle. Then it exists for this whole chunk in the middle, up to 5. 5, you call this an asymptote. It doesn't exist again. There is no value, right? You can keep getting closer that way, keep getting closer this way. There's no value there. And then it's going to exist all the way out to infinity from there, 5 to infinity. Range on this one's a little bit tricky, but you're going to have some easier ones to warm up, so that'll be nice. Range on this guy is the y values. Where does this exist y value wise? Does it go all the way down to negative infinity? Because you start at the bottom. What's the bottom?
Negative.
It keeps going down, here or here, right? On both pieces, it goes all the way down. So negative infinity. Here it goes all the way up until like 0. But over here it's going up even a little bit higher. How high does this look according to my picture? I think that's as high as it gets. Then there's a gap. You guys see the gap? So I think it only goes up to 1. Bracket or parenthesis on this one? Does it actually become 1 or not? Is that actually a point there or not? Yes. There's no open circle there or anything like that. It's there, right? That's part of the blue curve. So that's a bracket, exactly. And then there's this little gap. And this gap, I think if this was truly the bottom, what do we calculate that bottom as? I think you guys helped me a second ago. Wasn't it 2.4? So let's pretend that's the actual exact bottom. So then it'd be from 2.4 bracket, and I think this piece keeps going up forever, so to infinity. So remember, when you're talking about domain and range, this is a trickier graph. Domain is just look at the picture. Where are the x values? Where is it in x values? It might not have everything. It might skip some values. It might just be one chunk from 5 to 12 or from 5 to infinity. It's all about the x values. When you do the range, that's all about the y values. Okay? So remember, domain left to right, same thing for these. Range bottom to top. That's how you do it. Okay? Why don't you guys take the rest of the hour and work on the front side of that worksheet. Do the rest tomorrow. All right, so I thought we could use a little bit more review if you want to see some more reading domain and range and just basic features off of a graph. So here's another graph, f of x. I think I made this one a piecewise function with 3 pieces. So first we just want to read some of the values. So what if we plug in 8 to the graph? So we're just going to guess on these. So if we plug in 8, 8's like right here. That traces up to about, looks like about 8, I think. So that's going to be 8, something like 8. If we plug negative 8 into the graph, here's negative 6. That means this is negative 8. So if I trace that up, I think we're going to go something like right here-ish. So that looks like it's going to be about 14. Let's see, if we plug 0 into the graph, there is no piece of the graph in this region. So what do you say? Well, 8 was defined as 8. Negative 8 for f is defined as 14. If you plug 0 in, there is no definition. There's no answer. It doesn't exist. So in math, we call that undefined. 0 has no y value definition for this graph. If I plug in negative 10, let's see, so negative 10, it kind of hits this spot and this spot. So if you remember, the filled in spot is the actual one that's the actual y value. So I think it's this one, which is 6. Okay, I'm going to change this guy. So let's see, let's make this 12. So different question, kind of in reverse, says when f is 12, when the y value is 12, what's the x value that gives you that? So 12 looks like it's going to go over here and hit it about right there. So what's the x value of this point? If we trace it down, looks like maybe like negative, that's negative 8, negative 10, maybe negative 9? Approximately negative 9. And technically this guy has an arrow, so it's going to grow up. So this guy actually is probably going to hit somewhere over here too, if this arrow continues growing. So let's just make a rough guess over here too. So if that's that, so that'd be 6, there's 12, let's just say also about 18. So there were 2 values that produced that y or f value there. So now domain, again, is going to be the x values that exist on the graph. So if I look at the graph, let's put our arrow back here. Starting from left to right, left side looks like negative 12 is where it starts with an open parenthesis for the open circle. Then it goes to negative 10 and jumps up here, and it keeps going, I think, until we get to negative 6. Now it never touches this thing, it never actually exists there, so it's open there too. Then it doesn't start again until we get over here, I think that's about 4. So we're going to say or union 4. Should this be open? I think it's actually existing at 4, so I should put a bracket there at 4. And then it's going to keep growing out to infinity. All right, range, we're going to do the same thing except y values, bottom to top. I think the lowest thing on this one is this y value, which is 4. So bracket 4. Then this piece alone keeps growing all the way up to infinity. So I think these pieces are completely irrelevant for the range here. This one goes all the way up to infinity. The fact that those are up above that means that it's like doubled there, but that doesn't matter. So there are values of the function from 4 all the way up to infinity. You can always find a value. So that's the range of this graph. Hope that was helpful.